in you or class exercise on the golden chip problem, which is basic dynamic programming. Well, it can be solved using dynamic programming. It can be solved other ways too. It can be solved using brute force if your search space is very small. But as you will see, this is like almost the perfect case for using dynamic programming. So let me add some extra a bigger test case. Yeah, okay, here we go. We have I made some test files. I made a JSON, so that should be easy to load up. Downloads. There we go. Okay. Day8. So again, you can submit your code in pretty much, well, it's up to you how it can be how it's working, right? But basically you can submit in any state, in any shape, in any stage, basically in any condition. How should I say? All right. So one person has submitted, right? Who has submitted? All right. Can we look at your solution?
Sure.
Sure. Let's do that. All right. Let's see solution. Yeah. So golden chip. Save. Yeah. All right. So actually, well, this I'll have to open this. Well, I don't think I have Python here. Okay. Let's take a look at this. So you have 5 minute grid, right? So you find the length, nice clean code, right? You'll see.
This is the real dynamic programming.
Yeah. So let's take a look. You have 0, 0 energy grid, right? So in comes grid. Eventually you have a 0 n for range m, right? And so starting grid is 0. 0, 0 is 0 for now, right? All right. Set the first column values as here as robot can only move down. So the first row values as also can move only right. Let's take a look. Yeah. So I guess I should draw it, right? So you set up basically, right? So basically it's a classical bottom up. Right, you start at the beginning, right, and it's called what the original dynamic programming was. You make a table basically, tabulation, right? So I would be interested to see if anybody did the memorization solution, which I think is harder. I think this is, yeah, you did that. And it works.
Well, no, okay, no, I did the tabulation.
Yeah, you did tabulation. I think here tabulation is more suited because it's kind of flows naturally. Again, the key part which was mentioned already of this exercise was that you are the robot, not you, but robot has a limitation, right? This is only right or down. It has no backseas, right? Next lecture is going to be a back tracing. There's no back tracing here, right? It has to move forward. It has to, well, not forward, but basically right or down in this case, right? There's no going back, no going left or up, right? Which sometimes could be a better solution, right? But here we don't. So a brute force solution. Did anybody try actually a brute force solution? Like I think it's even harder than the tabulation here. You have to like get all the combinations basically, right? You know, it's to have a full search. I think it's even harder than this tabulation solution. But here, the key insight is that if you are here, right, you only care, right? You pick which path. You only have two paths. You only can come from here or here, right? Right. So you pick whichever costs less, right? And that's it. So that's simple. So eventually, right, you keep filling out the table. You build up the rows and columns, right? So again, so here in this example, so 1, so here what would be the value? It's of course you add 1 plus 2, right? So 3, right? And here you have 6, right? Cost is 6 here, right? Because you have no choice, because up there's nothing, right? You don't have choice. Same goes here. 1, then you have 5 here, and you have 12, right? Yeah, 12, right? Costs 12 to get here. There's basically no other way, right? So, but here you have a choice. The first time you have a choice, right? So 3 or 5, right? So this means here, what do you have here? What do you enter here?
8.
8, exactly, right? 8. So here you have 8. So here you have 8, and you have 12, right? Right? Yeah, 12. So here it will be 8, 16. 16, yeah. And that's it basically, right? So you fill out this table, and that's it. Yeah, very, very simple. Simple when you explain it, I think, right? But if you miss the part that you can move, you only can move on right or down, the search space might grow more, and you end up looking for some graph algorithms, for shortest path algorithms, which will look in about 2 weeks, right? Yeah. So, and of course, okay. So what else? Where else did you go wrong?
Considering edge cases.
Yeah, some edge cases. Yeah, let's look at some edge cases and see again. So basically, you can go off the grid. Of course, here also another consideration. In this case, right? Does it matter the columns and rows? Does it matter here? Like which way do you look? Like which way you look at the structure in this way? In this way, right? Sometimes you, like right now it's 3 by 3. Right now this completely doesn't matter, right? But if you have different shapes, right? Like 3 by 5. Should it matter? Well, what do you think? What do you think? Does it matter how you look at this problem vertically and horizontally, right? How do you process? I mean, the row and column here in this case. Well, what do you think? Should it matter or not in this case? You're not sure.
Wait.
What I'm saying, okay, I'll show you why am I asking this? Because, for example, right, when I was creating my example grids, right, so I said 12 by 8, right? So 12 by 8 is 8, well, and this is 12 rows, so 8 columns and 12 rows, right, sometimes, right? This means 12 rows, 8 columns, right? But it could have, you could also think maybe it should be 12 by, maybe 12 should be here and 8 should be here, right? Is this going to affect the solution?
No, it shouldn't.
It shouldn't. Yeah, it should not affect the solution, right? Because the operation is exactly the same, right? Right or right and down, right? Same type of operation. Rows and columns work same. Again, in this case, this makes your life easier. You could basically not worry about how you print it out, how you look at this problem, right? But it could be sometimes that rows and columns could have different operations. Then you have to pay much more attention, right? And that's something that you could kind of fall into, like sometimes, typical error. Basically, you mess up the rows and columns, basically indexing things like that, for example, right? That could also happen. Yeah, and that's also where you could also have bugs. That's possible too. If you have bugs with row and if you have 5 by 5 or 3 by 3, right? No worries. But if you have something rectangular, right? You could have you can go off the grid basically. You get the index error basically. You go off the grid. Okay. Now, so let's see a little solution. This is basically what I expect to see, right? I don't see anything. I don't see any obvious errors. So we'll test it. We'll see if we can find some non-obvious errors, right? So. All right. So we initialize. We said so again. As we said, we keep adding the values, right? Again, of course, you could write some other way. Maybe somebody use list and comprehension, something like that. But this, I think this is simple enough. Okay. So yeah, you have to start with the second value. We initialize the beginning, right? And then we start with second until the end, right? So, okay. Now, so we keep building the grid, right? Down and right, and now we populate the rest of the grid. So min, which is built in Python, is great for this. Again, you don't have to find it, make your own min function, right? Minimum energy grid. The previous, up or down, basically. You have the values already, right? And you add the value which is already there, right? So from the grid, right? And that's basically you return the last value, basically, right? And that's it. Very simple, right? So. If you got something like this, that's basically the solution. Again, of course, there's multiple ways you could think. You could call these rows and columns if you want, right? Things like that, of course. What else? What else? Does something have something completely different approach? Maybe, I don't know.
I have a similar approach, but the implementation is in a different style, I guess.
Yeah.
I wrote it like I would write C code, not Python.
Okay.
But using Python.
Okay. Yeah.
I'm not comfortable with Python.
Again, you can use C if you
Yeah,
want.
yeah.
On your midterm, you can use C if you feel very comfortable with C or JavaScript. I don't know, whatever you want, right? It's not prohibited. But I expect most will use C because it, yeah, yeah, you'll spend more time. And also, like I said, I let you use Copilot or any other AI tooling, but of course, again, be very careful with that because, of course, occasionally there will be some subtle mistakes, especially if your problem, the AI can miss some of the conditions, right? And then the solution will not work, right? It will look very good, right? But it might not be the correct solution actually, right? So you can't just say, okay, I'll feed in the problem description, right, and I'll let ChatGPT solve the problem completely for me. It might work to some extent, right, but not completely. That's just I'm warning you, right? But it's again, I'm not against it, because it's of course these days, like for you guys, using some AI systems that's the future basically. It's inevitable basically. Right, the productivity gains are huge. Of course, for learning, it might hold you back a little bit. But okay, it's just another tool, just like calculator. So, what else? Anything else we could want to see? Well, let's taste it maybe. Right. So you have the grid, hardcoded grid. Right. I'm just going to add it to the code space. It's Krista's solution. Now, if you don't mind, right, I'll put it here. I'll put it in a notebook actually because it's easier for me. A sample solution. And I'll put here. Kernel, yeah. So 13, right? Yeah. So let's do a bigger grid. And of course, I'll load the grid here. Yeah, let's do that. Let's take a look at this sample solution. Oops. JSON is not. Yeah, I need of course import JSON. Yep. Okay, and now let's run it on this one, right? All right, reload. Let's take a look. So, 61, right. So what we could do, of course, is, again, let's just add the bug, basically, here. I'll add the bug, like or verbose, right, verbose is false, right, and if verbose, right, I will print here at the beginning, at the end, right. If verbose, basically, yeah, for row, print row, basically, yeah, I guess that's good enough, right. So, and of course, now let's try it again, verbose, and yeah, okay, and you can see clearly what's happening, right? So, and of course we can find the original grid too, right? Where's my original grid? Here we go. I'll make a split here. Yeah, yeah, that looks like it, right? Okay, looks good, right? So 20 here. Let's see, 6, 15, yes. And let's see, is it correct? Something doesn't look like right. Wait, what's wrong? 6, 11. Oh yeah, it's fine. It's 11, of course. Yeah, everything's fine. Yeah, obviously top and bottom here is fine, and you can see how, yeah. So again, at each step you check whichever is cheapest, basically, right? 766, right? So again, so now of course challenge printing the actual path, right? What's the actual path? It might be a good exercise actually, right?
I did that one in my code.
You have it actually. Okay. Yeah, that'd be actually kind of useful, right? Well, of course, this asks only for the final solution, right? Okay, but for final result. But we would want to find the actual path taken. So how would you? Okay, now the question is, how could you, if you did not do it, well, how would you print the solution? Any ideas?
Well, you start from the bottom right
Yes.
and then go.
Yes, very good, excellent, yes. So this is a good point, yeah. So this can also lead to, so that's often a good trick actually. It's a very good trick often in any type of graph of sort of traversal, going back. So, because here we don't know the path we're going to take, right? It looks, this looks good, right? But we don't know this moment, right? Here we don't know which way we're going to go, right? Right, it looks like it's going here, right? You see here is 19 here, actually, 16, 19, right? So actually it turns out, this actually looks much better, right? But again, you don't know exactly. So what you do is, you start here, and you take the minimum, right? You take, which one? This one, for this one here, right? You take 53, because this is 8, yeah, you take this one, right? You take 51, which one you take? 50, right? 48, 40, well, here is a tie break, right? It happens, right? Tie break, 47, 47, right? Because this means that both, where is 47, 47? Ah, yes, both are equally likely, and this means, well, it's all fair, right? Again, either solution works, right? There is no tie break specified, so you pick whichever you want, right? So it means this means, of course, there's multiple solutions to this particular puzzle, right? You take 47, you take 42, you take, of course, 36, right? Because that's how it came, right? So this approach of going backwards is tracing your path back, basically. Well, kind of like back tracing, basically, right? You're going back, right? So, all right. So let's see if we can find the given the path, right? Given the energy grid, right? We want to actually print the solution. All right, let's do that. So you have it.
Yep.
All right,
I just submitted it.
Okay, let's take a look since I'm lazy. All right. You are?
Edwards.
Edwards. All right, so there's main. Okay. Good old notepad. Now we'll do code. All right, so you have the big grid. Right, on print.
Yeah, I didn't name the function, but the transform is like get the energy and then I have another function
Okay.
for.
Okay. All right. So you made a copy, and with the idea, so you basically just instead of initializing with zeros, you just copied, right? Okay, and then you overwrote. That's a completely valid approach. Of course, it could be sometimes could lead to some trouble if you somehow don't fill out the table completely, right? If it's all zeros or something, or all like sentinel values, nulls or nuns or something, it's easier to catch errors. But it's fine, of course, right? I'm just saying I would not, of course, grade you down, of course, or anything like that. But it's just I'm saying, yeah. Get result after before, right? So length unit. This is so you start. Is this where you get the result?
Yeah.
Yeah. The solution, well, row is more. Okay, yeah, you start at the end, right? Yeah, yeah. Okay. Okay. This is. I think this works. I wonder if I think you could probably do this recursively, right? It would be a really short solution, recursive again. But this is fine, of course, right? So you have our row, unit, and unit is what?
Like I guess a column.
Column. Okay. Yeah. Again, try to use common names, because then, of course, makes life easier, right? Unit, of course, is fine because we're too general, right? Column would be probably better, or what else could we use? I don't know. So probably see row and columns, I think is or X or Y, but row or column I think is the best in this case, right? So unit is a little bit just the name is too generic, and but at least it's not a cat name, right? Right. Don't use cat names in your solutions unless the exercise is about cats, right? Right. I told you the story about the cat, the student, right, who gave cat names in his exercise, right? on flowers, whatever. I don't know. This is a big mess. So okay, but yeah, it's fine. It's completely fine. Looks like so a pen, right? I'm curious if we could do it recursively here. So while row, while unit, right? So after before, and we have solution on where is your date? Where do you start with? You have a solution.
And then I just reverse it outside the function.
Okay, yeah. This is yeah, get result. Row, okay. And you call the
Above. I call it at the start.
let me see here. Okay, so wait, what do you call it?
Yeah.
Okay. Delete solution 0. Solution. Okay. After. Okay. After means the grid after.
Yeah.
Okay. After transform. Okay. I got you. Okay. Solution reverse. Okay. Delete solution 0. Okay. And solution append. Okay. All right. That sounds good. I can run this one as well. Alright, let's take a look. Where are we? See if there are any problems. Of course, this is a little bit dangerous. I'll probably put it in separate. I'll call it another solution. Full solution or pass solution is pass. Let's take a look. Now let's take a look. It should run, right? Force Control Enter. Runs. And here's the solution. So this is actually you print the actual energy cost.
Path,
Yeah, but of course this is good, of course. But of course, better to actually see. I guess the actual coordinates, I guess, be another way to do it, right? Yeah, you have some ID from that, right? But of course, you can easily change instead of 6. We could do a tuple here. Let's fix this up, right? You find this part here, right? Yeah, all of these, right? We replace all of those with a tuple of row and unit, basically, right? Right? And okay, the question is this gonna do you don't have to worry about solution. Yeah, okay, let's do that. So what I'll do is, this is going to be Control D, right? A bunch of Control Ds. So Control D, Control. Oh, it doesn't work. Control D doesn't work on code spaces. That sucks. Sorry about that. Sorry for my English, for my French. But I thought it worked. Or Control D. Come on. That really makes.
Replace all.
Yeah, because that's not what I want. That's pain. Okay, but we'll do that. Okay, so Control F, right? Yeah, and we do this replace. No, what is it? Replace with same thing. Oh, come on, what's happening here?
In VS Code, I think F2 is a shortcut, but it mostly works for variable names. I'm not sure.
Yeah, of course, but not for the full line. No, I would use no. So yeah, of course, you know Visual Studio Code. Yeah, you can use specific variable names. You can replace unit with column, right? For example, right? No big deal. That's good too. But what I want to select these whole bunch of these lines, right? Just some particulars, basically. So basically. Here I want to replace this part here with this part here, basically a tuple, right? Append the tuple of row unit, basically, right? To see where we're going, basically, right? Of course, we can do everything. Well, since we have tuple, in fact, I'll do this. I'll go full stop. We'll use this, and we'll also use basically row unit like this, and we'll add the extra. Parentheses, right? That should work. And this replace all, or is replace all?
No, because in other places it's unit -1, row -1. So.
Let's see. Yeah, it's possible.
So you can't replace all.
No, yeah, so not as clean as I would like. Okay. Yeah, but we'll try this. So it worked only one place. Everything else is yeah. So we'll do it over again. You see, that's the thing. Okay. All right, so Control C, Control.
It won't work because.
It'll work. It'll work again. So the tuple.
Unit row minus 1, unit minus 1.
Oh yeah, but then I have to. Is it row minus 1? Yeah. So yeah, that's. Oh, it's possible. It's completely legal. And unit, right? 2. Yeah. Okay. Or 3. Okay. Okay. Let's see if this works.
Oh, you did it the other way around in the. Like in the first.
Yeah.
You did row unit and then the value. No, you did value row unit. But
Which one?
like on this line you did the value first and then the row minus 1 and then unit.
Oh yeah, you're right. Completely right. Completely right. And so again, apples and oranges. So that's the thing. Is all by 1 errors, right? And again, of course, it's not never ideal, right? You want to do it one way, and of course, then you end up on, the other way. So again, I have to do this again here by hand. I guess I see unit minus 1 like this, right? And of course, you can use some other structure to represent this path. You can get really fancy. So here I have to replace this, right? Yeah. So okay, 1 second. 1 second. Yeah, more like here. Obligāti, jā. Apsiltējums, 8 sekundītes. Es tev atceros pēc tam minūtēm. All right.
One more.
Okay, so row before, and one more, right?
Yeah, slightly above.
This one, yeah. All right. And this one is again row unit minus 1. Okay.
I think maybe in the main function you also need to change a bit, like go up. No, not here.
Here?
More up.
Oh,
Like, yeah.
print solution.
No, in that. Yep.
And this starts with top. Okay, yeah. So it starts with. We start at the bottom, right? So you want this part here, basically, right? We want. So this would have, of course, you can see this would be nice to actually use variable, like calculate them before, right? Pre-calculate something if you're actually going to use them again, right? And of course, yeah. So this is why code gets a little bit in the if you want to start doing more, this really is already begging for a little bit of refactoring with some variables here, right? Like in the other solution we saw here, right? Use the which one was it? This one here, right? Getting the M and N basically, right? Here, I'm keep redoing it, right? Keep reinventing the wheel, right? So let's do it. Oh, it will break. It didn't break. Well, it worked, right? So 0 1 0 0, right? 0 1 0 1, right? That's 19. 0 2. That looks like this one, right?
Yeah.
Yeah. 0 3 4 still goes up to here, I guess. Is that possible? No.
No.
Here. Yeah, let's see. Yeah, it goes here. Yeah. 1 4, right? No. Okay. Yeah. So yeah, so you can see it. Of course, again, with these tuples, that's just again another quick and dirty solution, right? Because it's hard to tell which one is which. Better way approach would be to use some sort of make a class for this, right? And so you have names or name tuple. Name tuple would be even better, right? Again, for those of you, if you have time to polish, you probably don't have time to polish, and it is not required in this solution. But again, let's go back to our solution. Is everyone clear on how this was done? Everyone, right? It's only a question of doing it, right? Right? So when you see this is very easy, but of course when you start actually implementing yourself, all these small details, right? These little off by 1 errors, things like that, right? So again, try to make things as simple as possible. What I added, this is again optional. If you want to practice a little bit of dynamic programming, I added another problem here, right? If this is not enough already for you guys, I added another problem to today's, right? And this is a pretty famous problem. I just renamed it a little bit. It's called game points maximizer, right? right? A little game, arcade, and things like that. Okay, but but basic idea is this: you have points, right? You can collect points from some levels, right? But you cannot play the next level, so you have to skip the next level, basically, right? So in fact, this is a very famous lead code problem. It's called house robber problem, right? You want to rob the houses, but you cannot rob the next house, right? So you want to collect the most loot, right? Of course, not morally a little bit dubious, right? But yeah. So basically, here's the idea, and this is in a way much simpler problem, right? But in a way, it's much harder because figuring out how to do it is a little bit harder. So you have this basic list of items, basically a list of numbers, right? And you need to get your strategy. So here solution is 3, 5, and 7, right? You start at the first one, third one and fifth one, or 0, zero based indexing 0, 2, and 4, right? So again, if you could check out the lead code, it's this one here, right? This is like a interview preparation site, right? It's pretty well known, right? So it's not going to be maybe just as won't be on midterm, but it is harder because I think figuring out your strategy, basically, right? So because at first glance seems like how can you figure out, because you seem like you have lots of freedom, but if you think about it, there's not that much point of there's no point of skipping over 2, right? For example, if you are here, right, there's no point of getting here, right? Because you can get this one immediately, right? And then you get that one, right? So you always pick either the next or the one after, right? So
well, technically, if instead of 10 there would be 15,
yes,
it would make sense to take 3 and 15.
Yeah, that's the thing. Yeah, you see, so if this is like 20, right, or let's say, or 5,000, okay, whatever, right? Yeah. So your strategy, you cannot go. You see, you cannot go 3, 2. You cannot pick the next one, right? So the winning strategy would be 2 and 5,002, right? So. But turns out you can keep, so you only need to keep track of 2 values, basically, it turns out, right? It is a little bit harder, right? It's a little bit of brain teaser, basically, as well, right? But the way to solve it is you can only keep track of 2 values, basically, of where you are or one before, basically, right? It's just like the one we just solved, just like this robot problem, only on one array, basically. But the hard part here, and that's why dynamic programming problems are so hard, is to figuring out that this is actually okay, right? Because you see this, you see immediately, you can see these counter examples, right? You see, okay, but how can that work, right? So the point is basically there's no point of skipping, like if you're here, right? You don't skip to, here. So here, if you, you're saying, so 3 and 5,000, right? Yeah. So let's see the rules, right? So here, 5,000, right? It would make sense to skip from 3 and 5,000. That's what you're saying, right?
Yes.
That makes sense, right? So also you have to compare with these 2 values, because 5, you see the thing is 5 is not used here then, right? So in a way you have to look at either you skip to here or here, basically, right? That's all you have to care. That's the only thing you have to really worry about in this moment, right? So another question, of course, is how about this one here, right? Right. Let's imagine this is like 1,000, right? So the obvious solution is 1,000 and 5,000 together, right? So how would you get this problem? Well, you go one by one, right? So you see, okay, at this moment, this 3 should go to this one, maximize this. That's the move you should make, right? At the moment, right? But if you're here, right, you maximize here. And the thing is, but then you get to this part here, right? And well, then you have to see which one was best, right? So it's harder to think about this through, but you only need to keep track of 2 values. Turns out, yeah. So this won't be graded, but it is I think it's hard to follow through why you only need to check two values at a time, basically. The base cases, right? Base cases are easy, right? Okay, now, so next, so on Tuesday we will look at the back tracing, the next tool, right? So hopefully today you were able to get some idea of dynamic programming, but not too bad, right? So. Okay, all right. So let's continue at 11:10, maybe 11:15. No, let's do 11:15 actually. We ran a little late here today.